So again, this is more of the calculus and context stuff, and I would not actually suggest starting a new page in your notes. We got like 2 ideas down last time, the derivative idea, the integral. I have just one last thing to add to that list, and that'll really be all we get in our notes. The rest of today is more from that calculus and context packet. Final thing we need to add. Given a function, h of x. We talked about derivatives, we talked about integrals. The last idea we need to get, though, is the idea of an average value. How do we find the average value of a function? There was a formula we had. That's a different average. Yeah, so you're thinking the mean value or the average rate of change of something. We also had a formula for the average value, like the average height of our function. There was an integral in there. What was that? What you people were mentioning was the average rate of change formula. The average slope, the average derivative, that's our h of b minus h of a over b minus a. But if I want to find the average height of my function, it's 1 over b minus a times this integral. And today we're not really going to be concerned so much with the average height, but more like the average number of cars that have passed through the intersection, or the average of this, or the averages in the real world. The units, when we do this thing. We said when we did derivatives, our units were the units of our function divided by the units of the independent variable. For integrals, that was the units of our function times the units of the independent variable. Here our units are just whatever the units of h are. Why? Well, because this integral gives me the units of h times the units of x. But the 1 over b minus a out front is going to divide by the units of x. So they'll cancel each other out and just give you the units of whatever function you were dealing with. In your packet of question? No. In your packet of examples, can you open up, please, to problem 5? And after you read it, I just want you to store the function in your calculator and then stop. Nothing else, just store it in there. We're not going to get anything else in our notebooks for today, but you may want to keep them out as a reference. Michael. Yes, although maybe some of the examples we'll look at might help with some of that. But
why is the units, you said it's the units of g of x times the units of x.
Let's wait till we see some specific examples today. I think it may make a little more sense after that. So right now, I need you reading number 5, and I need you storing that function in your calculator. And by the way, especially people who are in physics, check the mode. Make sure you're in radian mode here. I will try the day before the AP exam to remind you, make sure to be in that mode. So hopefully you're stored in the calculator. Now, Part A is asking us to find the average temperature. Part B is asking us to find the average rate of change of the temperature. These are different things. In Part A, we were given the temperature, and I want to find the average temperature. I want to find the average of the thing we were given, as opposed to B, where I want to find the average rate of change of the thing we are given. Because Part A is the average of what you're given, we're going to use that that average value formula that I just gave you. We're going to do 1 over, I'll figure out the A and B, I guess, right now. What's A and what's B? We're told that T is hours after 9 a.m., so 9 a.m. is T equals 0. 9 p.m. is T equals 12. So I'm going to do 1 over 12 minus 0 times the integral from 0 to 12 of t, one's capital, one's little. Sorry, it's bad notation, but whatever. Temperature, time, done. And whatever this gives us should give us the average temperature over the course of the day. If it was me, I would ignore the 1 over 12 out front. I would just do the integral and then multiply the answer by 1 over 12. But go to the calculator. Let's get an answer. It may take the calculator a few moments because remember what it's really doing is one of those like area approximation things with a whole lot of rectangles, like a million rectangles there. So it's going to take some time to calculate it. So you've got your function stored in the calculator. We're going to math. We're going down to option 9, fn int. I'm going to integrate from 0 to 12. I want to type in the name for that function. I stored it in y1, so I'm going to bring up the name y1. I have one I was going to use in the other class, but I need to take one, I'll make more copies. Is it saying fn int? I think I mentioned this last time. If it's saying fn int, your notation is fn int. You first type in y1, then you type in your variable, then the lower limit, then the upper limit. We need to give it those 4 arguments. When you're done, I guess it did go quickly, but it may not go quickly. Type no, push the variables button, go over to function, and select the name y1. Are you getting that 706 and all that? That's not the answer. What do I have to do?
Divide by 12.
The average temperature should be about 58.913 degrees Fahrenheit. If you integrate, it actually gives you something that doesn't really mean much at all. Degrees Fahrenheit times like hours or something like that. But because of the 1 over 12 minus 0, you're dividing by the hours. It canceled that out, just giving you degrees Fahrenheit over there. Nathan. Well, no. We had...
Did you say it was net change?
Whoa. There are 2 things we can do with the... If we just do the straight integral, it gives us the net change of the thing we're dealing with when you integrate a rate. We weren't integrating a rate. This is that new thing we just put in our notes. To find the average of something, we can do 1 over b minus a times the integral of that thing we're dealing with. I want to find the average temperature, so if I integrate the temperature, but don't think about that part, think about the integral times 1 over 12 minus 0, I get the average temperature for the day. As opposed to part B, where I want the average rate of change of the temperature. You have the temperature, you want the average rate of change. This is stuff we looked at last time. This means I need to do t of 12 minus t of 0 over 12 minus 0. I've shown you how to just evaluate on the calculator, right, with the y1 in parentheses, 12 and all that. I think it's kind of an interesting answer. We'll talk about why it makes some physical sense in a moment. But see what you can get for your average rate of change of the temperature. Like the plugging in part? Okay. So I need to bring up the name for y1, variables, go over to y variables, function, y1, and to evaluate at 12, in parentheses, you're going to say 12. Minus, bring up the name y1, in parentheses, say 0. When you're done, we'll divide by 12. Not that it really matters. Are you getting 0? What kind of units? Degrees Fahrenheit per hour. A, because this is like a derivative, where our units are the units of T divided by the units of the independent variable. Or, well, temperature minus temperature, that's degrees. Hours minus hours, that's hours. Degrees per hour. Why does this make some sense? That the average rate of change between 9 a.m. and 9 p.m. is 0. Your temperature is going up. But then later it's going down. It's kind of going down the exact same amount that it went up. Those changes have canceled each other out. That's the idea. It's not saying the temperature is not changing, but it's saying on average, the increases cancel out the decreases. Okay. The rest of today, as we work through the rest of this packet, you're going to notice that when I cited my sources for these, a lot of these were either old free response questions or adapted from old free response questions. At least one, if not two, of the questions will involve some of these ideas. And the kind of annoying, but also why they did this part, is they try to throw a lot of different calculus ideas into these things. We may have to do an integral here, maybe a derivative here, maybe some interpreting here, maybe an absolute maximum or an absolute minimum. I'm going to try to show you as many different variations of this stuff as possible through these examples. The homework tonight will be not terrible calculus and context stuff. I'll save the harder stuff for the night after. Right now, I would like you to read number 6, and I would like you to store that function in the calculator and do nothing beside that. Just store it in there. So we're getting this stored in Y1. I assume it's in there. Okay. I have the rate that water is leaving this tank. I want to know how much total water has leaked out by time 10. Do I care that it could hold 100 gallons?
No.
Not for this. Hands if you have an idea. Arjun?
For B, this is how large the tank is to track.
Okay, so we're going to get there in a moment. Let's look at A, though. How can I figure out... Brady?
Sorry, I got you can take the integral from 0 to 10 of R to dt.
That's all we're going to do. Integrate the rate that water is leaving from 0 to 10. You will get the net change in the water, which is like the water that is left.
R, B, and A are actually the same thing, though. One, they're just like different parts of like the same thing, like
Yes,
so I think
because they're two different questions. We're going to use similar ideas in B. Let's do A, let's get an answer. We can either start B from scratch, or we can use our answer from A to get us B. You're absolutely right. Go to the calculator, integrate, please, and put units on that answer. DK, do you have a number? Good. Gallons, sure. I was integrating gallons per minute. Remember our rule when we integrate something is the units become these units times the units of T. So gallons per minute times minutes, gallons. Total amount of water that is leaked out.
So you can just say gallons, not gallons of water.
Gallons is fine. There's nothing else in the problem. It's not like we have two different things. So Arjun, how would we do part B?
I'm still part A.
Okay. Question about A, or you want... So how are we going to do B? Yeah. If we were starting from scratch, it would be 100, the starting amount, minus the amount of water that is leaked out. But I think we could really just do 100 minus the answer you already got. This is probably good notation, though, to write, even though you're not going to recalculate the integral again. What will that give you? 76.345 gallons.
On the AP exam, would they want us to read that?
They would want to see like what sort of actually, they wouldn't give you A and B together on the exam. They'd probably just give you B. You wouldn't have already calculated the integral. So yeah, you'll need to include that in the notation. Now, C and D. C, what's the average rate that water is leaking out of the tank? D, what's the average rate of change of the rate that water is leaking out of the tank? Now, what is the function you were given? What is R of T representing? The water in the tank? the rate that water's leaving. Here's where the average thing gets a little weird. Do I want just the average value? Do I want the average rate of change? And the way I try to think about these is, do I want the average of the thing that I was given? If so, 1 over b minus a times the integral and all that. Do I want the average rate of change of what was given? That's the f of b minus f of a over b minus a. C, what's the average rate that water is leaking out of the tank? Is that the average of the function you were given, or the average rate of change of what you were given? You were given the rate that water is leaking out. I want to know the average rate that water is leaking out, the average of what you were given. That's going to be our new formula, not new, but that's going to be our formula we got in the notes from today. 1 over 10 minus 0 times the integral from 0 to 10 of r of t dt. Go calculate that, or use a shortcut to calculate that. And figure out your units for this thing.
Can we just do what we done before?
That would be the shortcut.
So because we're already working with a rate, it's like finding the average values.
Yes. What makes this tricky is definitely a language thing, and it all comes back to what is that original function. If your original function was the amount of water in the tank at different times, we wouldn't be able to do this. But because it was the rate that water was leaking out, I want to know the average rate water was leaking out, that's why I'm doing it this way. I assume we just took A and divided by 10?
Yep.
2.366
Yep.
units. Gallons per minute. That's that new rule I gave you. Units of this thing divided by units of that. Well, it's really just the units of the original function, which was gallons per minute. We just took the answer from part A because we already done the integral. And if you didn't see that, just do the integral from scratch. Part D is looking for the average rate of change of the rate that water is leaking out of the tank. Eliza.
Maybe I wrote this wrong, but if you were doing the notes for the formula you gave us today for units, it said units of each, right?
What are the units of R of T here?
Oh, okay.
That's
so
why.
Not just gallons.
No. It's all a matter of what that original function is. Please go do part D, average rate of change of the function that you were given. Which I hope is just this problem over here, because it's the rate of change of the thing you had.
If you don't use R, you can place the operation.
Yes, you could say square root of 10 plus 1 minus square root of 0 plus 1, but you've got to show what you're plugging into. I think R is simpler than writing out the square root form. Definitely you'd lose points for F because there is no F in the problem. Does 0.232 look right? What kind of units? Hour or minute, first of all? Minute. Yeah. This is gallons per minute, or gallons per minute squared. It's the rate of change of the rate that water is leaking out. We know that water is leaking out at a certain rate, but is that rate itself increasing or decreasing? That's what I found over here, the average of that.
It's kind of like the constant between the velocity and acceleration.
Exactly. Yes. Anything with this? So this one wasn't from an AP exam. This was just showing you the differences in the averages. And again, it really all comes back to the language. What is the original function? This would be a very different problem if the original function was the amount of water in the tank versus the rate water's leaving. Go to number 7. Store that in the calculator. And I would like you to do part A. This one did come off an old AP exam. Store it in the calculator. Do A, but don't do anything else after part A. Read number 7, store it in your calculator, and do part A, please. So I think this is where we're going to see that. So let's do a calculation, then we'll talk through our units. are you about to plug into f, do the derivative of f, or do the integral of f? You have the rate that cars are passing through the intersection. I want to find the total number of cars. Well, that's like the change between time 0 and time 30. We need to be integrating f of t dt from 0 to 30. And because of the directions, when we're done, we're going to round to the nearest whole number because we're talking about the number of cars. Nope, they won't. But since I'm going to round to the nearest whole number, I'm going to change it to approximately. Nitish, are you set with that one? What do you have? Sounds good. Do you realize why it's an integral? Traffic flow is the rate. Cars are going through this. Integrate the rate, you get the total amount. Okay, so Michael, F.
No, I see.
What was that? To the nearest whole number, yes, because the directions say that. That's why. You understand why it's cars? Perfect. Okay, now, Ronak. Because we do that when we're trying to find an average. This is not an average problem, it's just a total number of cars. And if I did do that, you know what, I kind of don't want to talk about, well, no. If I did do that, that would give me the average of this thing we're dealing with, the average traffic flow over an integral. That's not what I'm looking for. This isn't what we just did today. This is what we got in our notes last time about integrate a rate to get a net change. Part B. Is traffic flow increasing or decreasing at t equals 7? Now, okay, we have the traffic flow. Traffic flow is f of t. I want to know, is that increasing or decreasing? So we have to look at the derivative of the traffic flow. We want to find f prime, not really of t, f prime of what? 7. I'd like you to go to your calculator, use the n deriv feature, and get a decimal for this, and then we'll interpret the answer and kind of answer our question. Math? Go down to option 8, and if you don't have the derivative symbols, there are 3 arguments there, y1, comma x, comma the number.
Are you using those symbols for everything?
Because I'm rounding the answer from the calculator. That's why. And if you don't, it doesn't matter. By the way, in the homework tonight, which will be this calculus and context stuff, you need to show work. By showing work, show me an integral, give me an answer. Show me a derivative. Don't just give me a number, though. Show me what derivative, what integral you're doing.
Wait, why can't you just use the original function? This isn't itself, right?
So, but that's not what I'm looking for. The original function is the rate that cars are passing through the intersection, so that would be like the derivative of the number of cars.
Oh, so it could be like 3, but then later it would be like 2, so even though it's increasing here, it's still decreasing overall.
No, maybe. There are 2 different things going on. I am not asking you, is the number of cars that have passed through the intersection, is that number increasing or decreasing? I'm asking you, is the traffic flow itself, is the rate that cars are passing through increasing or decreasing? And I'm going to go back to my favorite example of the whole start of COVID thing. Cases were increasing in New York, but increasing at a decreasing rate. That's what this is talking about. We know that traffic flow is still happening, but is the flow itself getting faster or getting slower? What is the answer for the number? Okay. It didn't ask us to figure out what this rate is, put units on it, interpret it, just go back to the original problem. Is traffic flow increasing or decreasing? Decreasing. We are asked to give a reason for your answer. Actually, I'm going to say traffic flow is decreasing. At t equals 7. Because. Say that again. F prime of 7, we've got to make sure we include that 7. F prime of 7 is less than 0 or is negative or something like that. I guess that part doesn't matter, but definitely over here you can ignore that because that's included in the question. For the justification, though, you absolutely need that. The other class was asking, couldn't you just say f prime of t at t equals 7? You can, but that's more work. I think this is the simpler way to write it out. But somehow you've got to refer to that 7 in your justification. Anything with this? I would like you to read C and D and see if you can A, tell the difference between them, and B, then see if you can calculate them. Average value of the traffic flow versus the average rate of change of the traffic flow. Those are our two types of averages. One will involve an integral, one will involve f of b minus f of a, all those things. See what you can do.
So always use the same terminology, average value, average relation.
Well, first of all, will you always have two questions like that? No. Usually you're going to have one, and you have to decide, this one that I have, is it an integral, or is it f of b minus f of a over b minus a? But I kind of don't want to say it's always going to work the same way, because if you have the rate of change and it asks you for the average rate of change, it would involve doing the integral. So I don't want to say it's always going to tell you one versus the other. The reason I picked this question out, though, is because we have that comparison we can make between C and D. Is C an integral or no? Average value of the traffic flow, you have the traffic flow. You want the average of the thing I gave you, that's the integral one. Versus you have the traffic flow, you want the average rate of change of the traffic flow, that's the f of b, well not f, but, well yeah, it is f in this problem. I think we should be doing 1 over 15 minus 10 times the integral from 10 to 15 of f of t dt. Versus part D, where you're doing the average rate of change of the function you were given, f of 15 minus f of 10 over 15 minus 10. Go get some answers and put some units on them. What was that?
All these formulas need to be memorized.
Yeah, so basically the ideas, we put it in our notebooks. Those ideas, yeah, you'll need to basically memorize.
Okay.
Although honestly, there's kind of only like 4 or 5 real ideas in there. And I think you already know what a derivative means and integral means. I think the biggest thing is just memorizing the difference between the two averages. Average value versus average rate of change.
Like, do we have to memorize that formula and that formula, or are you giving it to us?
No, oh no, you don't get any formulas.
Okay, so yeah.
Yes, you'll need to memorize that. Anna, do you have an answer for part C? I almost like it. Yeah, so with the average value, the units are just the units of whatever F was. F was the traffic flow in cars per minute, so yeah, it will be cars per minute. Or, sure, I bet you said cars because the integral gave you cars, but because of the over 15 minus 10, you're dividing by the time. That's why it's really cars per minute. Decimals are fine here because this is not the number of cars. This is just the rate cars are passing through. Decimals are fine with a rate. Ronak, do you have an answer for D? 7.5 or 8, either would be fine. What kind of units? Exactly. Cars per minute, or really just cars per minute squared. This is not the rate of change of the cars. This is the rate of change of the flow of the cars, of the rate the cars are passing through the intersection. Prima. Whoa. No, we did that for part C. We said the units are h of x. For part D, we wrote that in last time, where we said the units are h of x divided by x. Yeah. Anything so far? I can't record more than a certain amount of time, so I'm going to